Hi guys, this is Dr. J here, and in this video we are going to understand oxidation and reduction reactions further. In previous videos I have discussed about the oxidation numbers for different elements in a chemical reaction. So in today's video we are going to use those oxidation numbers to identify oxidation and reduction, and also we are going to use those oxidation numbers to balance chemical reactions. So in here I have a simple example for oxidation reduction reactions. In here I have a reaction between copper metal and oxygen gas producing copper oxide. Okay, copper oxide. And as you can see in this reaction, uh, basically copper metal oxidizes to copper 2 plus ions. Okay, copper 2 plus ions. So copper metal has an oxidation number 0, and copper 2 plus ion or copper oxide, the copper in copper oxide has a plus 2 oxidation number. So in here the oxidation number has increased from 0 to plus 2, which means it is an oxidation. So this is an oxidation. For oxygen, let's consider oxygen. Okay, so for oxygen the oxidation number is 0 for the molecular oxygen, and in copper oxide the oxidation number is -2. Okay, so when it comes to oxygen, the oxidation number has decreased. So therefore the oxygen molecule turning into oxide ions can be considered as a reduction. So indeed this copper reaction with oxygen is an oxidation reduction reaction. Why? Because certain reactants, in fact copper is oxidized and oxygen is reduced. So therefore you can see an electron loss from copper and electron gain from oxygen. Okay, electron gain from oxygen. So furthermore, in this slide I have shown you the details about the oxidation and reduction. So as I mentioned earlier, copper metal has been oxidized. Why? Because it is going from 0 oxidation state to plus 2 oxidation state. So your oxidation number is increased. So therefore this is an oxidation. This reaction is an oxidation. Okay, so we know that now. And in oxidation we learned that it is a loss of electrons, right? So when copper is converted to copper 2 plus, 4 electrons has been lost. So these are the 4 electrons. Okay, and then when consider the molecule oxygen converting to oxide ion. Okay, so oxidation number for molecule oxygen is 0 and oxide ion is -2. Okay, so the oxidation number is decreased in this half reaction. So basically if the oxidation number is decreased, we call it a reduction. So in here oxygen is reduced. And copper is being oxidized. And and also during reduction we expect a gain of electrons, right? So as you can see, molecule oxygen is gaining 4 electrons in order to become 2 oxide anions. Okay, 2 oxide anions. So that is your reduction. So in this reaction, I have separated the copper reaction and oxygen reaction as 2 different reactions. So in other words, even though both copper and oxygen react together, I have separated it into 2 steps. So these 2 steps that I have used in this slide, we can say these are half reactions. Okay, these are half reactions. Why do we call them half reactions? Because copper will not go into copper 2 plus ions just because it can, okay? It will not self-oxidize, okay? Which means copper will not lose electrons just without any reason, okay? Which means there should be someone else to gain those electrons, okay? So I mean, the two reactions that were listed in here, will not happen independently. They need the other reaction to survive. Oxidation reaction need the reduction reaction to survive, because if someone is losing electrons, there should be someone else to gain those electrons. So oxidation or reduction cannot happen independently. That is why we call them half reactions. And by adding these two half reactions together, you can obtain the complete reaction or the full reaction, okay? By adding the two half reactions, you can get the complete reaction. So I'm going to take a notepad and I'm going to rewrite this reaction and explain how to write them, okay? All right, so the first thing that you have is copper oxidized into copper 2 plus, okay? So you have copper metal, okay, oxidizing into copper 2 plus ion, okay? So this is the oxidation half. How do we know that it is oxidation? Because it is losing electrons. How many electrons is it losing? It is 2 electrons, okay? If you don't know how many electrons it is losing, that is fine, okay? This is how you do it. Okay, you first take the oxidation numbers. So this is 0 and this is plus 2, okay? What is the difference between 0 and plus 2? 2, right? 2. So this right here is your oxidation, and the difference between oxidation numbers is 2. 0 to plus 2, difference is 2. And during oxidation you are losing that many electrons, which means 2 electrons, the difference between the oxidation numbers, okay? So this is your oxidation. And let's talk about the reduction. Okay, what you have is is oxygen, okay? O2 gas, okay? O2 gas getting into oxide ions, okay? So it is becoming oxide ions, and the oxidation number is 0 for molecule oxygen. Let's use a different color so that we remain consistent. Okay, so let's say oxidation number for oxygen is 0, oxide is -2. Okay, these are the oxidation numbers. Then there is something important that we need to understand here. So you have 2 oxygens in the molecular, on the reactant side, and you only have 1 oxide ion. So you have to balance it first, right? So you need to put 2 here. Why? Because reactant side has 2 oxygens, or product side should have 2 oxygens. Okay, so let's talk about the difference between oxidation numbers, okay, going from 0 to -2. So this is your reduction, and the difference in the oxidation state is 2, okay, 2. But here is the thing, you have 2 oxygens, so the difference is 2 per oxygen. So the total difference is actually 4 electrons, okay, because each oxygen is 2 electrons, so the difference is 4 electrons, okay? So that is the difference in electrons, okay, 4 electrons. All right, so these are the two half reactions, oxidation and reduction, okay? During oxidation, copper metal oxidized to copper 2 plus, releasing 2 electrons. And when molecule oxygen goes to oxide anion, 2 oxygens are involved, and each oxygen is gaining 2 electrons. So you have 2 oxygens, so you need 4 electrons. So these are our half reactions. So let's number them. So this is our first half reaction, this is our second half reaction. Okay, so in oxidation reduction reactions, both oxidation and reduction happens at the same time, okay? But here's the thing, so in oxidation you are losing electrons. In reduction you are gaining electrons. So when you are adding the half reactions, you have to make sure that the electron loss and gain is balanced. In other words, you have to make sure that the electrons were lost from the oxidation has to be equal to the number of electrons that is gained in reduction. So which means you have to consider the difference, or you have to make sure that the electrons are balanced. So in order to balance 4 electrons to 2 electrons, you have to multiply the first half reaction by 2. First half reaction by 2, which means you are multiplying everything that you have in the first half reaction by 2. Okay, so therefore when you are writing the overall formula, you have to put 2 copper, okay, because we are multiplying it by 2, and then 2 copper 2 plus, and then of course we have 4 electrons. Okay, so in here in the full reaction we are adding 1 and 2, okay, the half reactions. And then oxygens already have 4 electrons, you don't have to do anything else, so put O2, okay, and then 4 electrons. And in here you also have to have 2 oxide ions, okay, 2 oxide ions. But as you can see, 4 electrons to 4 electrons will cancel out each other, so you don't have to write the electrons. That is why we are balancing the electrons, okay. So we have to balance electrons. So when we are adding the half reactions, there will not be an excess of electrons in one side. That is why we multiplied the first half reaction by 2 and make sure that the electron loss is equal to electron gain. So this is your final reaction. This is a balanced reaction, by the way, okay. This is a balanced reaction. How do we know that this is balanced? Because the electron loss is equal to the electron gain. The electron loss is equal to the electron gain. Okay, so if you go back to your slide, you will realize that the equation that we got is basically the same as the equation that I have in this slide. So that is how you balance oxidation reduction reactions. Okay, you will identify the oxidation, you will identify the reduction, and you will try to make sure that the electron loss in oxidation is equal to the electron gain. When those two are equal, you can simply add the first half reaction to the second half reaction and get the final complete reaction without electrons, of course, without electrons. So that is how you balance oxidation reduction reactions. But of course there is an easier way. Okay, there is an easier way which I'm going to teach you next. But that is how you balance oxidation reduction reactions using half reactions. So I will teach you a easier method in a few minutes, but let's flip through the slides that we have and then try to understand this oxidation reduction reactions further. Okay, all right, so in here I have a reaction between zinc and copper 2 plus. Okay, so we have done this reaction in the lab, okay, where we had a copper sulfate solution, and then once you insert a zinc strip, okay, what you notice is that the blue color of the copper sulfate solution will diminish, and also there will be a copper formation on the zinc strip. Okay, so basically in here what happens is that copper 2 plus in the copper sulfate solution will turn into copper, okay, will basically reduce to copper. This is reduction, by the way, this is reduction. It will reduce to copper, and then zinc metal will oxidize to zinc 2 plus, will oxidize to zinc 2 plus. Okay, so it will go into the copper sulfate solution. So how do I know which one is oxidation and which one is reduction? You can simply get the oxidation numbers and identify it. Okay, so let's write the oxidation numbers for zinc and copper components here. For zinc metal, the oxidation number is 0 according to rule number 1. Okay, and copper metal, the oxidation number is 0 according to rule number 1. And then copper 2 plus iron, the oxidation number is plus 2 according to rule number 2. And zinc 2 plus, the oxidation number is plus 2 according to rule number 2. Remember, simple ions have an oxidation number that is equal to the charge. Okay, so now you have the oxidation numbers. So once you have the oxidation numbers, you can easily identify oxidation and reduction. During oxidation, the oxidation number is increased. During oxidation, the oxidation number is increased. Okay, so this right here is your oxidation. During reduction, your oxidation number is decreased. So copper half is your reduction. This is your reduction. That is how you identify oxidation and reduction. And then some other terms that we learned: oxidizing agent. Okay, oxidizing agent is the compound that helps oxidation. Okay, that helps oxidation. So copper is your oxidizing agent. Why? Because copper helps zinc to oxidize. It helps zinc to oxidize. Okay, so copper is your oxidizing agent. The agent that helps oxidation is known as the oxidizing agent. Okay, so copper 2 plus is your oxidizing agent. Okay, so who is the reducing agent here? So the reducing agent will be zinc. Zinc will be your reducing agent. Why is it the reducing agent? Because it will help copper to reduce. So the chemical compound that helps reduction is zinc. How does it help the reduction? Because zinc will oxidize. That process will help the reduction. Okay, so zinc will be your reducing agent. Okay, so that is how you identify oxidizing agent and reducing agent. And also in this reaction, zinc is being oxidized, and copper is being reduced. Okay, copper is being reduced. In here, copper is being reduced. Okay, this right here is being reduced. Copper 2 plus has been reduced. So now we learn how to use all the technical terms, like, oxidation numbers, oxidizing agent, reducing agents, oxidized and reduced compound. We learned all of these things using oxidation numbers. So now you know why we learned oxidation numbers. Okay, so in here, let's quickly do this study check. Okay, identify each of the following as oxidation or reduction. Okay, or reduction. So pause the video now and see if you could do this. Okay, so I'm going to give you the answers now. In here, tin is going from tin metal to tin 4 plus. So oxidation, what happens to the oxidation number? It is increased from 0 to plus 4. Okay, it is going from 0 to plus 4. This is actually oxidation. Okay, this reaction right here is oxidation. Why? Because the oxidation number is increased, and also it is removing 4 electrons. So this is oxidation. Oxidation number is increased. Let's talk about iron. Okay, iron 3 plus. Okay, the oxidation number of iron 3 plus is going from plus 3 to plus 2. So what is happening to the oxidation number? The oxidation number is decreased. How? By gaining an electron. So this right here is your reduction. Okay, this right here is a reduction. And let's talk about chlorine. Okay, the chlorine oxidation number is decreased from 0 to, is increased from 0 to -1. So your oxidation number is increased. So this right here is what? Is reduction. Okay, so this is reduction. Why? The oxidation number is decreased from 0 to -1. Okay, 0 to -1. So the first reaction is oxidation, second reaction is reduction, third reaction is reduction. By the way, these are not complete reactions. None of these three are complete reactions. They are half reactions. Remember, oxidation couldn't survive without the reduction and vice versa. Okay, so none of these three reactions are independent reactions. They have to have an opposite reaction coupled to it. Okay, if it is oxidation, there should be a reduction. If you are losing electrons, there should be someone to gain electrons. Okay, all right, so those are the answers. Okay, so let's see if you could do this study check really quickly. Okay, really quickly, pause the video now and then see if you could do this. All right, in light sensitive sunglasses, UV light initiates an oxidation reduction reaction. Okay, all right, so the reaction is given here. Okay, first of all, whenever there is a reaction given, I want you to identify the oxidation numbers. Okay, for silver, the oxidation number is +1 from rule number 2. Chloride, the oxidation number is -1, once again from rule number 2. Silver, the oxidation number is 0 from rule number 1. Chlorine gas, the oxidation number is 0 from rule number 1. These are the oxidation numbers. Now, once you have the oxidation numbers, okay, you can connect the relating species. So Ag plus will be connected to Ag. Chloride will be connected to chlorine gas. Okay. So for silver half reaction, the oxidation number is decreased. Why? Because it is going from +1 to 0. So this is reduction right here. This is reduction. For chloride, the oxidation number is going from -1 to 0. So it is increased. So this is oxidation. Well done. Okay. If you have these two correct, okay, then you are learning. Which reaction is oxidized? Of course, which one has an increasing oxidation number? Chloride. So chloride has been oxidized, which is reduced, Ag plus. Ag plus. Okay, why? Because oxidation number of silver ion is decreased. So that is reduction. By the way, if I ask you to show me the oxidizing agent, okay, silver plus will be your oxidizing agent. This height here is your oxidizing agent. Why? Because by reduction, Ag plus or silver ion helps chloride to oxidize. Okay, and then chloride is going to be your reducing agent. Why? Because chloride helps silver ion to reduce by accepting electrons. Okay, so these are your oxidizing agents and reducing agents. With this example, I'm going to stop the video. Okay, and I will be publishing another video on balancing oxidation reduction reactions using oxidation numbers. Okay, I know I briefly mentioned it in this video, but I mean that is a very long method that I showed in this video, which will not be helpful if you want to balance a chemical reaction in a quick manner. Okay, so we will be discussing on balancing oxidation reduction reactions in detail in a separate video, but you guys have a good one. Okay, take care.